Okay guys, we're going to try and do some canceling of fractions. This is a really handy thing to do when you are multiplying fractions. It's almost like you're reducing the fraction before you do the multiplication, because as you know, multiplying your fractions can end up giving you some fairly large numbers that you then have to reduce. So it's a little bit easier to reduce them up front if you can. So you just have to follow a few steps. So I'm going to give you a few examples. This is my first time using this, so I'm going to try and keep my stylus nice and quiet because it seems to be loud. So if we have 8 over 15 and we multiply it by 5 over 16, automatically you should be noticing that if you have 15 multiplied by 16, you're going to get a fairly large number. And then we have to start figuring out, how to divide it back down when we reduce. So one other way of doing it is you're actually looking diagonally across the fractions. So if you notice, this multiply sign has a line there going diagonally, and we have another line there going diagonally. So what you're doing is you're canceling the fractions as they go across in a diagonal formation. So this group of numbers we want to compare, and then the 8 and the 16 we also want to compare. So what I'm going to do is first look at what can I divide 5 and 15 by. So you're looking at factors of both of those numbers. So I know that both of those numbers can be divided by 5. So I'm going to go ahead and do that. So I'm going to cross out the 5. I know that 5 divided by 5 equals 1. I know that 15 divided by 5 equals 3. So I'm no longer dealing with 5 and 15. I'm dealing with 1 and 3. Also, I can look across this side and I can say, what can both of those numbers be divided by? So what are the common factors of those numbers? And I know that 4 goes in. I know that 8 also goes in. So I'm going to try to get the largest number I can. So do the greatest common factor. So 8 divided by 8 is 1. And 16 divided by 8 is 2. Now, I'm going to erase that for a second because I'm going to show you something. If I chose 4 or 2 as my answer, say we choose 4. So 4 goes into 8 twice, and 4 goes into 16 4 times. I can then look at what my two numbers left over are, and I can say, hey, I can actually reduce that further and say 2 divided by 2 is 1, and 4 divided by 2 is 2. So it doesn't matter if you use a smaller number, but if you get the greatest common factor, it'll work out more quickly. So now instead of multiplying 8 and 5 and anything that I have here in the white, we're going to multiply the blue numbers. So I'm just going to rewrite this so that you can see what it ended up being. So I've got 1 over 3 now, and I'm going to multiply it. So that's this group and this group. I'm going to multiply it by 1 over 2, which is that number and that number there. So now I know that 1 times 1, because I'm just going to multiply across and multiply across. So my numerator is 1 multiplied by 1 is 1. And my denominator is 3 multiplied by 2 is 6. I'm going to check to see if I can reduce that number, and I can't. So that one's finished. Moving on to mixed numbers. My first step with mixed numbers is to always turn them into improper. So that step has to come first. So let's get this guy down. So 2 and 2/3 multiplied by 2 and 1/4. I'm going to multiply those through to get the improper fraction. If you can do it in your head, great. If you can't, still, I'm going to show you the step. So we're going to do 3 multiplied by 2, and then we're going to add that other 2 to it. So you're kind of going in this clockwise formation. I'll do that in green for Greenhill. Clockwise formation. And then this one goes clockwise as well. So 3 times 2, 3 multiplied by 2 wholes, because that tells me that I have 6 total pieces, plus the 2 extra pieces left over. And I'm still dealing with the fact that my fractions are broken into thirds. And then in this one, I've got four groups. Remember, I'm still learning. 4 that the fraction is broken into, multiplied by the 2 wholes that I have, plus that 1 extra piece left over, and they're all broken into 4. So 3 times 2 is 6, plus 2 is 8 over 3. Don't forget your equal signs. We're going to multiply that by 4 times 2 is 8, plus 1 is 9 over 4. And then now that we have our improper fractions, now we can check to reduce. So I'm going to follow the diagonal again, and I know that I can do divide by 3 for both. They're both divisible by 3. So that turns into 1. 3 divided by 3 is 1. 9 divided by 3 is 3. And then I know if I look across to this 8 and this 4, and you don't have to draw these circles, I'm just doing it for you, or these ovals, sorry. 4 and 8 are both divisible by 4, so 4 divided by 4 is 1, 8 divided by 4 is 2, and then remember, we're just going across. So again, I'll rewrite the whole thing. 2 over 1 multiplied by 3 over 1. You can probably see what's going to happen here. Now we get 6 over 1, which also equals just 6 wholes. Okay? One last one just to show you kind of a semi-non-example. So I'm just going to put a little red line across here just so that we divide this stuff up a bit. 3 over 5 multiplied by 2 over 9. Now, if we look diagonally, we can see that the 3 and the 9 across here. I'm trying to get rid of these ovals for you because you don't really need them. It's just to help you see what I'm doing here. 9 and 3 are both divisible by 3. That's the greatest common factor, so I'm going to divide them both. 3 divided by 3 is 1. 9 divided by 3 is 3. But if I look diagonally across this way, I do not have a common factor that's divisible by, that both 5 and 2 are divisible by, except 1. So I wanted to show you this example because I don't want you to think that it has to be both sides. So now if we come across, we can do 1. 1 times 2 is 2, and then 5 times 3 is 15. Now you still want to always check to reduce. So say for instance this ended up being 3 out of 15. I know I have to reduce it further, but 2 out of 15, I know that 2 is a prime number. 2 can't go into 15, so this is reduced all the way. If you did 3 over 5, I'm going to do one last thing. Or maybe we'll do this, 3 over 5 times 2 over 9. You get 6 out of, 45? And I'm not saying that you have to cancel because you should be able to still reduce that number. But the reason why canceling is a lot easier is it just reduces it down a little bit more for you to help you out. Makes the numbers a lot more efficient to calculate. And you're also going to be doing a lot of these type skills when you get into complex algebra and dealing with more complex numbers. So canceling, I think, makes it a lot easier. But again, it's entirely up to you. But I would strongly suggest it. It will help you in the future. So I hope this clarifies because I know you have a ton of work to do with mixed numbers. So check to see if you can cancel at all times because I noticed in the homework I assigned you today that quite a lot of those questions are dealing with larger numbers. Okay? Message me if you have any questions.